Welcome to Artificiality, brought to you by the founders of Sonder Studio. Artificiality is a podcast dedicated to understanding the emerging community that is humans and machines. We take the latest in the human side, decision science, psychology, and design, and put it together with advances in artificial intelligence and big data so that you can understand how to work better with machines and your fellow humans. We founded Sonder Studio to help people be more human in the age of AI. We're on this learning journey too, so we strive to find the frontiers, to ask the best questions, and stay curious. We interview some of the top minds working at the intersection of humans and machines and make sure we have a few laughs along the way. If you enjoy our podcasts, please subscribe and leave a positive rating or comment. Sharing your positive feedback helps us reach more people and connect them with the world's great minds. Many of our listeners will be familiar with human-centered design and human-computer interaction. These fields of research and practice have driven technology product design and development for decades. Today, however, these fields are changing to adapt to the increasing use of artificial intelligence, leading to an emerging field called human-centered AI. Prior to the widespread use of AI, technology products were powerful yet predictable. They operated based on the rules created by their designers. With AI, however, machines respond to data, providing predictions that may not be anticipated when the product is designed or programmed. This is incredibly powerful, but can also create unintended consequences. This challenge leads to the questions: how can we design AI-based products that provide benefits to humans? How can we create AI systems that learn and change with new data, but still provide consequences intended by the system's designers? These questions led us to interview Ben Shneiderman, an emeritus distinguished university professor in the Department of Computer Science at the University of Maryland. Ben recently published a wonderfully approachable book, Human-Centered AI, which provides a guide to how AI can be used to augment and enhance humans' lives. As the founding director of the Human-Computer Interaction Laboratory, Ben has a 40-year history in researching how humans and computers interact, making him an ideal source to talk with about how humans and AI interact. Ben, thank you very much for taking the time to join us on the podcast. We're excited to talk with you.
Thank you, Dave and Helen. Great to be part of this.
I guess to kick off, I'd like to hear you explain what drew you to write this book. What was the journey to getting to this book?
Yeah, the book is called Human-Centered AI, and it's a slight shift from what's been my lifetime commitment to human-computer interaction, and user interface design. So I've been devoted to developing the technologies that support what people want to do and empowering people. And the current excitement, appropriately, is about artificial intelligence, machine learning, deep learning, neural networks. And it's become such a dominant issue that I felt there was a need to address it. But for all my career, I've had my concerns about AI, and I've written regularly about those issues, about how a human-centered approach, the notion I call direct manipulation of visual representation of the objects of interest on the screen, and be able to click and drag and swipe and so on, all those tactile experiences, and see a graphical user interface and drag a file and drop it into the trash can and hear it clink. All of those things were really important in the success of the technology. So direct manipulation become a widespread foundation for Apple and Microsoft and other guidelines. And it's what's made the success of those 2 or 3 million apps on the app stores. And so I felt that those principles were being eroded, let's say, by the early thinking in AI, which assumed that the machine could do it and the user didn't need to do anything. The machine would figure out what you wanted and deliver it to you, rather than giving you the sense of control over the technology. And I found myself troubled by that idea. So that's the starter, and that got me into it.
I find it a fascinating starting point. I mean, in a part of our work is doing design work, product design work, and we take a human-centered approach, as you would expect, designing applications and so forth. And we came at it very much from the same standpoint as you, is that we came at it after spending multiple years in the AI space and trying to understand what all of these new algorithms were going to do, and then scratching our heads and wondering how to adequately and appropriately design an application when the machine itself can make so many decisions on its own. You know, our history is a bit long in the technology space. And I remember my first products that I shipped went out on a CD, or at least the updates went out on floppy disks. And it worked the exact same way we'd instructed it to for absolutely every user. But now we have these worlds where these things change and they make decisions based on the data you've input. And so I find your statement about thinking about the transition from the direct manipulation of user interfaces, right, where people can drag and swipe, but now the machine is looking for us to give it data, giving it human behavior data to respond to, and to generate new predictions from the models. And that's so difficult to figure out how to design something where people are in control of what they're used to. They think they're swiping. That's the direct manipulation. I'm moving the slider. But what you're actually doing is generating human behavior for the machine that it doesn't know, and you don't know what you're doing. You don't know what's happening. You don't have the knowledge of what the machine is actually reading from you.
I think you've got your hands on part of it, but look at the language you were using even there. We all fall into it. The machine is looking for you to give it, and you're personifying the machine. And that's a strong part of the hype of AI, that the AI, the algorithm machine is becoming conscious, becoming aware, becoming intelligent, becoming super intelligent, becoming, acquiring general intelligence and common sense reasoning and sentient behaviors. So all of that hype has distorted the design thinking. And so the AI community has a very different outlook than the HCI community. The HCI community looks towards user studies, observations of users, interviews, and that social connection with users. Whereas the AI community is quite devoted to the idea of the machine being autonomous, of it working on its own, and there being an AI as a sort of being in the machine. And yeah, it's a compelling notion. It sure is attractive and has brought many people into this field, but it's also misleading. I may not go so far as to say it's a deception, which suggests intent, but I think it's suboptimal. And the belief that people are like machines seems to be the problem for me. I see people as very different. People are distinctive. They're capable. They're brilliant. They're creative. They're remarkable. And I value and celebrate the distinctive capabilities of people. And the rapid increase in human capabilities over not just centuries, but even decades and years, where the human capacity to coordinate and collaborate with other people gave them in the early days the capacity to take down a mastodon, or to form agricultural communities, build cities, make corporations, put together armies, make these elaborate social structures, governance that allow human society to be so rich and diverse. I mean, humans are not just naked standing on the beach. Humans are defined by the technologies that they use, the tools that they have, and what I call the super tools or the AI-infused super tools of this day. And so for me, the great example is the digital camera, where there's lots of AI going on to set the shutter speed and the focus and color balance, reduce hand jitters, all kinds of great AI going on. But you, the user, point your camera, zoom to what you want, frame it the way you want, and then you click for your decisive moment. It's your picture. And that camera gives you a great degree of control over the things you care about and lets the machine do what it does well to adjust the shutter and focus. That mostly works well. You want to be able to override it when the focus is wrong, or you want to change the color balance, and those kind of features are built into most of the digital cameras. So that's what I see as a success story, giving users control over the aspects which make them creative, make them responsible for their pictures, and then let them do what they want to do.
I really like the multiple ways that you sort of you kind of come at this conundrum of what humans are good at and what machines are good at and how to put them together. And there was a section in the book about the way that you can start designing AI with almost taking the parallel of a human-human relationship rather than a human-machine relationship. And I'm wondering what you think is the limits of that, because when people do take that approach, it can be really quite successful when you're talking about a particular kind of interaction, and it allows people to build a mental model of what they want out of the relationship with the machine. But at the same time, what you point out, which is very true, is these super tools, we're not going to unlock them if we just think about them being like humans. In that digital camera case, imagine trying to design that with another human being the digital camera. You'd end up just having arguments about where to stand and at what point to press the shutter. You wouldn't be talking about these super tools of focus and being able to do sub-second kind of behaviors. And how do you think about coaching people through understanding the limits of designing for that human-human interaction metaphor versus unlocking the super tools of AI?
Oh, Helen, what a challenge! But I've heard this before. There's a long and ongoing thread of discussion that says, well, people relate to each other. Humans are relating to other humans as partners, teammates, and collaborators, and therefore machines should be partners, teammates, and collaborators. And I don't think so. Or let's say I think that's a suboptimal design strategy, that when you're lured into that, because it's a compelling design idea, you wind up with things that don't really work that well. So I've become a critic of this human AI team notion. And a lot of it's based on Cliff Nass's work at Stanford University, who did dozens of studies with his students that showed that people responded to computers in social ways. And so the theory of computers as a social actor emerged. And so that led people to believe that that was a good way to design. But in my lively discussions with Cliff, we really liked each other, but differed. And sadly, he died very young. But, I would say, it's true, people respond socially, but that doesn't mean that that's the best design. And again, when I looked around at the designs that were succeeding commercially, they weren't teammate designs. They weren't social. The digital camera is not social. GPS navigation is not social. There are ways in which the user can express their intent. I want to go from Vancouver to Washington, D.C., or take a trip or a drive, and they get a set of choices guided by AI. They choose which of the routes they want, and then they get going. But they can change along the way. So they're not locked in. It's not a social relationship with my GPS navigation. It's not a social relationship with my digital camera. The social relationship in digital camera is with my friends and family, to whom I can easily send the photos I've taken. And I can crop and edit them and select from what I've taken. And they're my photos. And when I take 100 pictures and send 3 to my family, I'm making choices. Those are what I choose. And so I think while the AI teammate notion is widely used, and I know I'm still in a minority here, I do think there are ways in which it limits design thinking, and that if you open up to a super tool notion and you design things that let people get what they want done, you have a better chance of making a commercially successful tool.
You're right. You are in the minority. The majority is very much we need to think about these interactions with machines in the same way that we would understand how to build trust with humans, which relies on our ability to gauge how correct they are, or how good their predictions are, or whether or not they're on our side. And as I am listening to you talking, it does make me feel a little skeptical about the teammate design, not just for the reasons you were saying, but also that it's kind of a convenient narrative for the AI community to almost sort of deflect concerns about machines as superhuman agents taking over our behaviors or manipulating us, more in that camp, by saying, well, if you design them socially, then you'll have your natural human characteristics of empathy or gauging trust. You'll be able to just see that the machine is trying to manipulate you. And the way you describe this makes me, I don't know, maybe I'm thinking more conspiratorially, but it feels like it's a handy story to sort of subdue us and stop us actually thinking about other ways to approach this design.
That's right. I think the AI teammate is so seductive and appealing that it undermines people's willingness to think about alternative designs. And yet, the social robot movement, to me, appears to be collapsing. 2019 was sort of a bad year for Jibo and Anki and Kuri and Pepper and so on. So it's, things are going poorly because social computers are not what people want. They want tools to get things done. The early bank machines were called automated teller machines, and they mimicked a human teller, and Tilly the Teller and Harvey Wallbanker and a lot of other sort of whimsical, playful ideas were put forward, but they're gone. And what's left is the advanced transaction machine, which with a few touches gets you your $60. And that's what people want. They want a machine which does what they need quickly and with minimal distraction. The social relationships are Simon Natali has a wonderful phrasing of this in his book about this. He talks about banal deceptions, which are lightweight ones, and then straight up deceptions, which are much more serious. And so it's something, I think, of a deception, or let's say inappropriate use to put up to pretend that a computer is like a person. Oh, it can work for a little while, and the first time out, it's cute and it's fun, but it doesn't seem to last. What seems to last, what seems to spread, what seems to be commercially successful is the notion of tools that get you what you want. Whether it's camera, GPS navigation, and so on, those are super tools that I'm very happy to use.
So what would be a super tool for things that people want to achieve socially? Like, how would we put those two ideas together and say, we know that people do want to achieve more, social things. So the way you described building societies or taking down the mastodon, what are the equivalent of that today? We want to achieve these social things, but we don't want to start by putting this false premise of it has to be a teammate with a machine. How do you encourage people to think through, and we might need to go to the frameworks in the book, but because this technology is so new and so not intuitive, it's so hard to understand how eye tracking and mouse clicks or, name any of these other sort of super sensory or super data-driven approaches. How do you let go of the social interaction metaphor and design structure, but embrace the fact that people might want to do that with other people?
Right. Human-human relationships are great, and we can use technology to support it. And text messages and email and cell phone and Zoom are all ways that people can be social with each other. The technology supports it. Lots of AI under Zoom, lots of AI in text messaging and in the optimal routing of messages to make them quick. Even, text completion and query completion for search. All of those are ways in which the AI boosts the capacity of people to work together, to communicate, to be social. And we can see the new research directions that I like, Microsoft's meeting coach. It's not an AI which, tells you in the meeting, speak up more often or stop interrupting others. It's not that kind of a character, but it does use the sensory technologies you describe to track what's happening. And then at the end of the meeting, the participants in the meeting can, if they wish, get a little record that shows how much they spoke, how many times they interrupted others, how many times they made eye contact or not. And it gives them a sense of feedback about what happens without being an interference. We know that kind of interference is unwelcome, whether it was Clippy in the old days of popping up to offer help or whether it's inappropriate AI techniques jumping up to give you a recommendation or make some kind of helpful suggestion. Now, there are some interesting special cases out there which are worthy of understanding. So voice user interfaces, Siri, Alexa, Cortana, Google Home, and so on, are an interesting special case. There's no physical manifestation. My Alexa is just a cylinder, and Siri's embedded in your phone. So there's no physical presence, not even a visual one that shows you a face. But the voice, my voice now can retrieve data, get information. And that's very impressive. It's very impressive. But it's quite different from human-like robots. And the design of that voice user interface has been carefully done and continuously improved. So there's a special case. Another special case which has success is the idea of pet robots for mild to moderate dementia patients. And a couple of them seem to be on their way towards a success. They're low enough cost that a patient can have their own and always available. They're furry and fuzzy, and they, respond in certain ways, and they seem to be helpful to people. So Tombot is one, Joy for All is another, and those are interesting cases where they seem acceptable. But in general, the nursing home robots that wander around that pretend to be humans have not been successful. So I think we should look at those special cases.
I'm curious how you think about the feedback loop of explaining what the prediction is that's coming from the machine, the recommendation in a recommendation engine, I was sort of captured by one of the examples that's part of the Google design team, where they described a theoretical, hypothetical app for recommendations for runners, where you'd run, it would measure your run, and then it would recommend, a new run to you. And one of their criteria was saying, and we're recommending this because you really liked this path over here that had lots of hills, or you really liked this run over here because it didn't have lots of hills, or something else. But there was that feedback loop to help you understand what was happening. Sometimes that's possible, sometimes it's not. But I'm just curious how you feel, what you think about that as part of that interface. Because as sort of going back to what I might have clumsily said before about direct manipulation, when you know there's a slider, you know exactly what you're doing. But when an AI is taking your user data and then using that data to make a prediction, you don't always know what data you're offering up, that it's using. Right? You're just using your phone and running. You don't know what it's actually measuring from that run and what it's doing.
From your description, you must have, as you started, you said you seem to like the path with hills. Well, how does the machine know that you liked it? Sorry, there I've used an anthropomorphic. The machine doesn't know. I think
in this particular case, the application was asking you to rate the run. So at least it would say there was a feedback loop that you were saying, I liked this run, or 1 out of 5, so whatever mechanism it was.
Right. So the question is, why did you like that run? Was it because the scenery was nice, because the run was level, because the weather was good, you were with people? All kinds of things can make you happy or unhappy. So sorting those out and understanding what makes people prefer one kind of run or another is a more complicated issue. If recommendations like that can work, I don't have any objection to it, but I guess I'm into the world of user control and offering sliders that said, more hilly or demanding, longer run, shorter run, scenic places, that you would give users the capacity to select. One of the examples I love is the charming one done by a group of British librarians. You really ought to give it a try. It's called whichbook.net, whichbook.net. And it's a recommender for novels. And you get a bunch of sliders that let you choose what you want. So you can slide from funny to serious, from beautiful to disgusting, from no sexual content to explicit sexual, and from optimistic to bleak. And as you move the sliders, the cover images of the recommendations change. So you know why they're happening. Okay? Now, there's a model underneath. There's data. Okay? And it's provided by other people. And yet you get to choose. Newspapers are doing this with sliders that say politics, sports, or entertainment. And you move the sliders to get what you want. So I think that's a useful approach. Remember, when you get into your car, you can adjust the mirrors and the lighting and the speaker sound and the temperature and the chair positions and so on. And so it's your choices. And one day you feel like having more light or a louder sound, and you have different needs on different days. And so I think when well designed, those kind of selections become just natural. Everybody expects that you can adjust these, dozen parameters in your car. And I think people should come to know and adjust the parameters of what they get in their social media, in their news feeds, in their movie recommendations.
Well, I like the example of the books because it does the simple to complex, the simplicity. There's a simple model for this super tool that's going on behind the scenes. Because if you design that like a human librarian, there'd be a lot of back and forth, right? Well, do you like this one? Do you like that one? It'd take a long time. There'd be a lot of annoying suggestions. But by putting the sliders all together, the super tool is that it happens instantaneously. So I like that example a lot and wonder how many ways that could be applied that people are underutilizing.
Yeah, I love your example of movies. We can sit and look at Netflix or Hulu or whatever else and get lots of recommendations, but it's pretty often that we're scrolling through going, this just isn't what we feel like. Yeah. But there's no way to change it. You're only seeing what it recommends. You can drill through the categorized, media, which makes you feel like I'm back in the old Yahoo browser, right?
But the only way to change it is to actually go watch something for 10 minutes.
Yes.
And then, and then the model updates and it gives you a different sort of series of recommendations. How do you like to think about the things that humans the difference with machine learning based models compared to traditional static interfaces, if you like? How do you like to think about how humans should think differently? How do we think more probabilistically or be more forgiving of the machine or think about that relationship to update, be more actively able to update the way the machine solves for us and the personalization that sits behind that?
I think you have to separate out the different cases, and I've been making the case that says there's actually many different kinds of AI situations. So recommenders are kind of a lightweight situation, and if you get a quirky recommendation, that might be fun and interesting. It's not troubling. But there are more serious, consequential financial recommendations, legal recommendations, and then life-critical ones like medical and transportation, military, and so on. And so, you have to understand the importance of each situation and the dangers of each situation. And then, especially military or medical, those people like to be in control over it. They don't want the machine to take over. And so, in the cockpit, there is no AI, okay, because the pilots want to know what's happening and why. And when the Boeing 737 MAX had an autonomous system, not AI-based, but an autonomous system built into it, where the pilots were not even informed of its presence. They were not informed when it was engaged. There was no visual display that said, okay, this is on now. MCAS is the system. And it resulted in confusion and 2 deadly crashes. And so in consequential applications, I think we really have to think about it, more carefully and let the users be more in control. And the idea of slider control is one way to accomplish it. So you're asking the right question. I'm asking for that question to be more nuanced and refined.
Do you have an opinion about what mindset allowed that the 737 MAX design to even be that way?
Well, I haven't spoken to the designers, but I've read, a great deal about it. And from what I can tell is they believe that they could make a system that would automatically compensate for the new designs of the aircraft. It was larger engines, and therefore the engines were put in a different position from previous models. And so to compensate for that, they built the system that would keep the plane level under normal circumstances. The refusal to tell the pilots was partially Boeing's fault and partially the customers who insisted that pilots not be retrained for this new version. And so there's lots of parts to the 737 MAX story, but I would say there was a general belief that it would be possible to adjust for this substantial design change in a 50-year-old plane and thereby not disrupt the training and practices of pilots. And when the indicator, the sensor, went bad, and another problem was there was only a single sensor, not dual sensors. The plane triggered into action this MCAS system and pointed the nose down. The pilots, not understanding what was happening, pulled on the stick to lift the plane, and more than 20 times in the 12 minutes, the pilots failed to figure out what was going on, and therefore led to the crash. So, your question was, how did the designers come to this? There were a lot of complex social and management challenges and pressures on them, and they maybe believed in this notion of autonomous machines that could be made perfect under all circumstances. And I have to say, I question that. That's why I list humility as one of the qualities you want to have in a designer who recognizes that this may not work. This may fail in ways I never thought of. The training data may not be what I really think it is. And again, we've seen that the training data misleads the model. And since the model is more opaque than transparent, we don't quite understand what's going on. So I'm a great believer in visual design tools to help deep learning, machine learning developers to know what the data is like, know how the system's performing, and be able to improve the system. I think Fernanda Viegas's work at Google is maybe the most exemplary here, where she showed how the visualization that she built into TensorFlow helped the designers understand what the model was doing. And so this pressure for explainability was not just for the users, but it was for the designers as well. And they were able to make improved designs because they had a better understanding, a better explanation of what was going on.
Yeah, and a better explanation of what might go wrong too. It's almost seeing that expands the mental model that the developers have of just what's at stake. One of the things I think that your book does a really terrific job of is embracing the many, many years in experience with traditional technologies and actually applying those in ways that are about where safety critical applications are more widespread now. Apple Maps and Google Maps could be considered to be a safety critical application. Models for loans. And we haven't even got to self-driving cars. But with pilots in the cockpit, highly trained, they were trying to avoid training more pilots because that's retraining them for this new model, which is obviously an expensive thing to do. But it's a bit dispiriting in some ways to think about how do you take everyday humans who want to be masterful at, say, driving their own cars and having them work with a degree of autonomy in their vehicles. There seems to be two different approaches being taken. One is like the 737 MAX, which is we'll just keep it all hidden and the humans will just take over when the button goes ping, which just in the context of everything you've written in this book seems like an absurd strategy. And as opposed to more driver assist technologies where the car doesn't drive itself, you have to drive it, but you can at least know that there's sort of a bigger safety net now, that airbag, it's not just the airbag, it's the fact that all of them, or the sensors around the car and the AI in the car is kind of like almost been a little bit of a co-pilot. But I don't know how we transition to this world where we're supposed to be really good drivers and yet we never really learn.
Well, you've got through a lot of interesting issues there. So let me try to pull apart a little bit of it. Yes, I believe the goal is safe driving cars, not self-driving cars. Let's get safe driving first. And so we can see that a lot of the assists, the ADAS, the assistive strategies, which support you to do parking, for example, is a good idea, or collision avoidance, or lane following. Those are all nicely designed specific features. And the Insurance Institute for Highway Safety does show that actually the collision avoidance that prevents you from running into the car in front of you does prevent more accidents. Okay? But the lane following prevents more deaths because the collision avoidance accidents are not as deadly as the ones where you leave the lane or you hit a car that's in your blind spot, let's say. So the collision avoidance strategies are good. We should put them to work. The lane following is good. They're even more important because they prevent deaths. And so understanding those nuanced differences of which features we want and which ones bring greater benefit is really where the research has to go, okay? And I'm into this decomposition strategy where you break apart the idea of self-driving, full self-driving, into dozens of small situations, and you design for each of those. So as you may know, the National Highway Transportation Safety Administration has launched an investigation initially of 11 deadly crashes where Teslas on autopilot ran into fire, police, and ambulance vehicles that were parked on the road or on the side of the road, because it turns out the Tesla algorithm does not recognize stationary vehicles. It does fine in preventing the collision avoidance of moving vehicles, but it didn't do fine in doing it. So understanding those specific things one by one will help us build increasingly safe systems. Just another part of your comment was about, the computer or the car as co-pilot. Well, we have let's say 50-year or more history of automatic transmissions in cars. And we see a success story there. Initially, people resisted them. They felt they could do better. They liked shift driving. And eventually, we've moved to majority, certainly a great majority, being automatic transmission because it's become more reliable. It is more energy efficient than most drivers, and it does the right thing. You can override for steep hills or icy days. So all those special cases are also included in the design. But it takes a while to get this maturation process right. And so I'm a great fan of, and one of the things maybe for your listeners, one takeaway message here you go. The audit trail, the flight data recorder for aviation has made civil aviation so safe because accidents happen, but the flight data recorder and the cockpit voice recorder give us a retrospective analysis that lets us find out what went wrong and make sure that the mistake that happened happens only once. Okay? So I want a flight data recorder for every robot, for every machine learning tool, for every mortgage loan decision, for every parole decision. And I think that's a valid research topic that's would be a great contribution to be able to understand for different applications, whether it's medical or transportation or banking or hiring, what is it that we need to track so that if somebody challenges or questions an outcome or a decision, we can go back and understand why that happened. So audit trails are a big deal for me, and I hope your listeners will follow up on that one. A related one is the incident reporting idea. We know in most industries that are, as you said, scalable, that grow big, there can be problems. So the Food and Drug Administration has an adverse drug event reporting system online. And there are thousands of reports of side effects that are put in by pharmacists, by nurses, by physicians, by patients. And from that, the FDA begins to track where the problems are. And it may actually change over time. So you have to continuously monitor that. And so those kind of tracking ideas would be very helpful. Sean McGregor, originally at the OpenAI group, put up an AI incident database that has more than 1,300 reports of AI incidents. And from that, we come to understand what works and what doesn't work. So I tend to look, as you've seen in the book, in a very more nuanced design way. What are the specific features that we need to build into systems to make them ethical, responsible, reliable, and so on? I'm a great believer in the discussions about ethics, but for me, it really comes down to design, where the designer has to make a specific choice. Do I do it this way or that way? And we need to expand the possibilities for designers to think of different choices. And then we need to let them record why they make certain choices and then monitor the performance. For significant choices, we could conduct studies where we build both versions and then we see how they work out.
What you're saying now reminds me of something I wrote down that you wrote. I'll just quote you here. It's in the context of your a comparison you make between rationalism and empiricism. That's one of the things you start the book off with, is this contrast in how so much of the AI community comes from a rationalist approach, and the HC AI community from an empiricist. But you wrote, the empiricists believe that researchers are enriched by the contradictions and ambiguities that come with real-world experiences and all the contextual complexity and diversity. And I think that's so beautiful what you're talking about, an audit trail. You're actually talking about capturing those, it seems to me at least, that you're talking about capturing those real-world experiences. You're looking for the contradictions, the ambiguities. You're looking for the contextual complexity. And you're looking to capture that in the real world as the AI is making correct predictions or making errors. So I'm interested, though, to go back to that core point of rationalism versus empiricism, because there is, it's in our experience, it's challenging to figure out where to put those two communities together or how to think about blending them. You have a world that comes from a data science background and which tends to be more rationalist, I think, and more of the design world tends to be more empiricist. I might be overgeneralizing, but I'm curious how you think about trying to bring those two worlds together, because they both exist, and I'm not sure that how to think about putting those two groups together to be effective.
Bravo, Dave. That was great. A fine analysis. And yes, I do open up with this chapter about rationalism versus empiricism. And it's a simplified model of the difference between these two communities, but it does help me see more clearly. And I was trained in a rationalist way as a scientist, and I apply rationalist approaches. And they're really both useful ways of thinking about the world. I don't want to abandon one or the other. I want people to understand that both give valuable perspectives. So the rationalist approach, if you can make a rational solution that really works, great. But the humility and the empiricist approach says, wait a minute. This may not work in every case. And as you cited the point that contexts are a very, very, very complicated situation. The contexts of use are dramatically different. And so it's very important for designers to understand that what works for one group of people may not work for others. I mean, it's users with disabilities, it's users of low literacy, users of different cultures and ethnic groups, and there's so many ways in which people differ. It's just startling. And vive la différence. But it does mean designers have to consider the range of things. And the good news is the experience shows when you think about a design that works better for many, many different communities, you actually make the design better for everyone. Okay? That's the beauty and the lesson of human-computer interaction, is that thinking through diversity helps improve quality.
It does. I find that interesting because the context is so important. You know, when we think about what machines are good at and what humans are good at, context is one of the ones that we definitely differ on. Machines aren't very good at applying the same routine in a new context, at least without new instructions. Whereas humans may not be great at it all the time, but we do have a pretty decent ability to take a learning from one part of life and apply it in a new context. We're at least better than a machine, which tends to be following the static routine. So I think the phrase contextual complexity and diversity is one that's really stuck with me on that. And I really appreciate the thought process on design. We both are captured by the work of Kat Holmes from Microsoft and her work on inclusive design, and thinking about that as a core strategic advantage in design. That once you think about designing for all communities, it makes the design overall, or it can. It doesn't have to always, but it can make that design better for everyone.
Right. The classic examples are the curb cut designed for people in wheelchairs to support their mobility. But hey, suddenly the roller bag becomes important and the baby carriage gets moved around, and workers carrying large pallets are rolling through the streets more easily. And it's safer. People less often trip on those curbs. So that curb cut produces a lot of benefits. And similarly, the closed captioning designed for those who were deaf becomes something that makes sports bars and airline terminals and so on, more livable, manageable. And then once you have closed captioning, you now have text that you can search, and all kinds of good things happen. So looking at the different contexts is a great a way of advancing good design. And that's a lesson that comes from the HCI community that I'd like to see adopted more often by the AI community, that they really think of the diversity of users.
Well, there's one of the themes that you have throughout the book is talking about reliable, safe, and trustworthy. And I was wondering if you could talk a little bit about trustworthy and what it is. You talk about trusted and trustworthy, but if you could describe a little bit about how you think about trustworthiness in relationship to an AI system.
Yeah, one of the challenges about writing about this field is there are so many terms out there. There's ethical and responsible and explainable and interpretable and resilient and certifiable, et cetera, et cetera, et cetera. And I chose those three, reliable, safe, and trustworthy, as a sort of planting my flag on a few of those. And so reliable, I focused on the particulars that engineers would do to make a system reliable. Safety culture was the manager's role to manage a safe organization in which there were teams doing reliable design. And then trustworthy was a larger framing in my mind that brought us into the ways of independent oversight and ways in which trustworthiness was built. And you make the point correctly that systems can be trusted, but they may not be trustworthy. And so the question is how we design for trustworthiness. In the US, the National Institute for Standards and Technology has a big role and a lot of effort about developing trustworthy systems and then assessing, not measuring, but assessing them. And I've been part of their workshops and trying to push forward ways to assess trustworthiness. In the book, there's a whole chapter that describes a method for doing just that. And it's about transparency, and it's about explainability and the features that you would put in the system that would make it trustworthy. So I think it's a useful concept, but we need to get a little more rational about thinking about how we assess trustworthiness. I'm not sure you can assign a number, but I think you want to be able to assess it. And the goals of assessment would be to say, if I have two systems that perform a certain task, is one more trustworthy than the other? Or if I have a design decision I'm about to make, will one decision lead to a more trustworthy system? And those are questions that I would say I've struggled with. I do my best in the book to present them, but there's still a long way to go in realizing them in real systems.
And trustworthiness has a relationship too to the owner of the algorithm, the owner of the model, if you like. Is it trustworthy? Is a model inherently more trustworthy in one company versus another, depending on the goals and performance of that company?
Right. I think that's another component, which is the independent oversight. If we see a consumers union or underwriters laboratory stamp of approval, we think of it as more trustworthy. And so these independent oversight mechanisms, which are getting built in, which have been built in, many existing systems, are coming now to the AI world. And so it will become a competitive advantage if a company gains a reputation of building trustworthy systems that its customers approve of, that makes fewer mistakes, that has open reporting and has a track record of improvement. So yes, as you suggest, we will come to trust if an organization, if a company has 10 trustworthy products and they have a new one, I'm more likely to trust them.
So would it be accurate to say that some of these aspects of trustworthiness and explainability and transparency and those, and more safety critical, the audit trails, are we going through the early stages, the growth, the adolescence, the growing pains, as opposed to some kind of crisis of AI causing irreparable harm? Is it growing? Because the audit trail, the way you're describing, I hadn't thought about having a flight data recorder, if you like, for AI models, but that's logical. But who reads it and who does something with it when there's a crash? At the moment, there are really strong nonprofits and lawyers who will take things on pro bono for people who have been harmed, but it's almost kind of grassroots compared to an FDA. There's no FDA for AI. Is that where we will ultimately go, do you think, or are we already sort of culturally pushing against that?
Yeah, your phrase of maturation is the appropriate one. We're still in the early stages where it's still Wild West, and individual researchers and startups put something out there. There's a great deal of hype about it. The journalists love it, and it gets promoted. But the maturation with serious large-scale companies, the banking companies, the transportation companies, have to begin to understand what really works and what's really safe, reliable, and trustworthy. So, these have to be developed over time, and there will be problems, and we'll come to refine these designs over time. So I'm optimistic that we'll get more of these AI-infused technologies, and I think it'll happen. My job is to make it happen in 15 years, not 50 years. Okay, and I think we're trying to accelerate the process that brings reliable, safe, and trustworthy systems that include machine learning algorithms. That's the goal.
If I could ask one final question. If you were given the opportunity to give, say, 3 points of advice to executives that are running companies that are trying to include more AI in their business, they're non-technical, but they're looking to add more AI. How are there a few things that you would say, this is what you need to put into your leadership and management plan in order to make it human-centered AI?
Yeah, great. The book has 15 such recommendations. And I love all my children. I'm
cheating by asking you to focus on a few. I know.
I love all my children, but
love all your children.
I would say audit trails and incident reporting systems would be a high priority one. Explainable user interfaces would be another one that I put in. And I would say safety culture would be a third, and then independent oversight. Companies will tell me that you'd be really impressed with the degree of care we implement AI systems. And I am impressed. I mean, the good companies are really doing an excellent job. They're really doing a lot of research and thinking, and they've installed systems to make these technologies as reliable as possible, to document them, to record them, etc. There's a lot of good work going on. However, that's only part of it. You need to have the independent oversight of the external organization. Just as in the U.S., the Securities and Exchange Commission mandates that companies, every publicly listed company, has an internal audit, okay, and an independent external audit. And that's where we need to go. So those are my four favorites: the audit trail and incident reporting, the explainability, safety culture, and independent oversight.
Excellent, thank you. And we won't tell the rest of your children that they're not your favorite. We really appreciate you taking the time to talk with us. We found your book is obviously beautifully researched and backed by many years of work, but it is also very highly readable. We highly recommend it. It's a great read for everyone.
In your summary as well, the need the trust and the need for institutions. You talk about the SEC and the FDA and the need for institutions. Not like me to be a pessimist, is it? But I do feel like there's something really interesting happening with AI at this particular time, this sort of intersection of crypto and AI and lack of trust in institutions, that if the big companies and the mature companies are moving further up the maturity curve, then maybe there's some, there is some sort of reason for hope that we have institutions that can help with this, rather than just be writing regulations that nobody takes any notice of.
Yes, thank you, Helen. I'm an optimist too. I think it's going to get there. I think these systems will be beneficial and widely used. As I said, my job is to make it happen in 15 years rather than 50 years. I want to get it right. I want to get it right sooner. I want people to benefit from these remarkable tools of digital cameras, and navigation systems and safer cars and safer systems of all kinds. That's where we want to get to. And I'm optimistic we're going to get there.
Excellent. Well, thank you very much. We really appreciate it.
Thank you, Helen. Thank you, Dave.